To find concavity, I now have the endpoints of my intervals would be -3, 0, and 3. Remember that 0 is the only critical number of the concavity, and aside from that, -3 and 3 makes the second derivative undefined as well as the original function. So I choose my test points to be -4, -1, 1, and 4. And I only actually need to plug it into 18x over x squared minus 9 cubed. Since this factor right here, x squared plus 27, this will always be positive. And I'm only concerned with whether the second derivative will be positive or negative. So I'm plugging in -4 right here. The 18x would be negative over -4 squared, that's 16 minus 9. That will be positive, so that will end up to be negative. Now for -1, plug it into 18 times x, that becomes negative, over -1 squared, so 1 minus 9, that comes out as negative. So negative by negative, that gives me a positive number. Then when I plug in 1, that's going to be positive over negative. That becomes negative. If I plug in 4, that will be positive over a positive number. So that gives me a positive number. So I have from -infinity to -3, I have concave down. From -3 to 0, concave up. From 0 to 3, it's concave down, and from 3 to infinity, the graph of the original function would be concave up. Now, I'm going to combine this with the increasing, decreasing. I know that the increasing, decreasing intervals that I have are as follows. I have from -infinity I have increasing from -infinity to -3√3, and then I have decreasing on -3√3 all the way up to 3√3, and then increasing again on 3√3 to infinity. And if I would like to combine that with the concavity intervals, you'll see that what I can use would just be the concavity intervals and put that together. So increasing from -infinity to 3√3,